Many men lose Y chromosomes as they age, and now we may know why it's so deadly. Errors in the human genome are part of life. As we age, the DNA replicates, small mistakes creep into our genes, a misplaced letter here or some erroneous repetition there, that can accumulate over time to create a mosaic of cells with unique codes throughout the body. Some cells can even wind up losing whole chromosomes. One example of this is a condition whereby the white blood cells are missing their Y chromosome, called amyloid for mosaic loss of Y chromosome. It's more common than you may think, occurring in roughly 40% of men aged over 70. Although the Y chromosome has long been considered a shrinking genetic wasteland full of dispensable chunks of DNA, missing a Y chromosome can have serious health consequences. The epidemiological studies amyloid has been associated with shorter lifespans and a greater risk of age-related diseases such as cancer and Alzheimer's disease. Now the condition could also be linked to impaired heart function, according to a new study mimicking the human condition in mice. For a while it's been unclear how losing a Y chromosome from blood cells leads to organ damage and disease in other parts of the body and ups the risk of age-related maladies, particularly cardiovascular disease and stroke. The team of researchers led by cardiovascular researcher Soichi Sano of Osaka Metropolitan University Graduate School of Medicine in Japan probed those questions a little deeper and have shown how amyloid triggers tissue damage that leads to heart failure in mice and is linked to cardiovascular disease. In the study, the researchers used the famed gene editing tool CRISPR to engineer mice with no Y chromosomes in their white blood cells to mimic the human amyloid condition. The CRISPRed mice lived shorter lives than unaffected mice and had increased scarring in the heart, a condition known as cardiac fibrosis that stiffens heart tissue and is linked to heart failure. Geneticist and senior author Lars Forsberg of Uppsala University said, "We see that amyloid in mice causes the fibrosis which leads to a decline in heart function." To test those findings against epidemiological data, the researchers then analyzed data from UK Biobank, a decades-long study that has captured genetic and health information of some 500,000 typical aging adults. They found men with amyloid in their blood at the start of the study had an increased risk of dying from heart failure and other types of cardiovascular disease during the on average 11 years of follow-up. This observation is in line with the results from the mouse model and suggests that amyloid has a direct physiological effect also in humans, says Forsberg. Of course, way more research is needed before we can map out the direct consequences of amyloid in humans, and keep in mind that losing the Y chromosome is unlikely to be the sole cause of age-related diseases, which are linked to the plethora of cellular processes gone array and a host of genetic changes that have accumulated over time. A University of Cambridge biologist, John Perry, told The Atlantic in 2019, after publishing work showing why some are more prone to amyloid than others, Y chromosome loss is a manifestation of broader genetic instability. Instability which is characteristic of cancer and signals that DNA has been accumulating errors faster than cells can fix them. Chronic inflammation is another suspected culprit underlying many diseases of aging, including cancer and Alzheimer's. So as Forsberg and colleagues note, there's more work to be done to untangle the complex interplay between inflammation and fibrosis and the role of amyloid in both. Returning to the mouse model for one last hurrah, Forsberg and colleagues also identified a possible treatment to ameliorate the effects of amyloid, blocking a signaling pathway that was activating the mice with Y chromosome deficient immune cells. the researchers noticed the ensuing fibrotic changes were partly reversed. The link between amyloid and fibrosis is very interesting, especially given the new treatment strategies for heart failure, pulmonary fibrosis, and certain cancers that aim to counteract the onset of fibrosis, says Forsberg. Although a potential therapy to counteract losing the Y chromosome in blood cells is still a long off, men with amyloid could be a patient group that responds particularly well to such treatment, Forsberg said. But knowing what we do now, stopping smoking would be a wise move as well, seeing as research also shows that men who smoke are more than 3 times as likely as non-smokers to show loss of Y chromosome in their blood cells. So smoking causes loss of Y chromosomes. This was a study published in Science magazine, and it's by Claire Watson on Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.